All right. Can you all hear me? Good. Good. Well, welcome. Thank you very much for our STEM Educator Workshop. And this time, we're very excited to have Katey with us. Very excited to have her. I'm Jason Bruns. I'm the director of the Minnesota State Engineering Center of Excellence. And thank you all very much for attending our event today. And thank you again to Katey for being part of this. And now keep in mind that we're also video recording this, and it'll also be transcribing as well. So that'll be available on our website. Those of you that are looking for professional development, all you have to do professional development hours. All you have to do is contact me, send me an email, jason.bruns@mnsu.edu, and I will fill that out and send it over to you. For those friends that were not able to make it today, please note that they can go to our website, watch the video again. I'll send them a couple questions just to make sure that they at least looked at it and watched it, and we can work our way through those CEUs as well. So let me happily introduce Katey. Shirey is a STEM education expert with PhD in teaching and learning from the University of Maryland. She has degrees in physics, sculpture, of all things, physics and sculpture. That already makes me think that's crazy. And teaching from University of Virginia. Dr. Shirey runs Educator LLC, where she designs STEAM curricula and professional development programs. She collaborates with organizations like ASEE, American Society for Engineering Education. That's where I first met Katey. E4USA and Knowles Teacher Initiative to inspire creative and real-world problem solving in students. And today's seminar title is Integrated STEAM Lessons Using Minnesota Content Standards, Structure and Planning. So the workforce focuses on aligning STEM and STEAM concepts with student learning standards. You as participants, will learn a Minnesota tested strategy for integrating content standards, and we'll have time to plan with a partner to create standards aligned lesson. The session will cover various aspects of STEAM education, including practical tips and strategies for effective implementation in the classroom, hands-on application. So what a great thing we're trying to do here. You'll also have the opportunity to engage in these hands-on activities, collaborative planning sessions, and what a great thing to be able to have aligned with the Minnesota standards. So with that, I'm going to shut up. I'm going to hand it over to Katey, and so happy to have Katey with us and Katey to be able to do this with us. So thank you all for joining, and questions or other things like that, you can put them into the chat. You can put them in the Q&A. We'll work our way through it together. This is a new platform that we're utilizing, so you'll have to work with us a little bit. I'll probably flounder somehow in here, but we'll work our way through it. So again, thank you all very much for joining, and I hope you enjoy what we have today. Katey, it's all up to you.
Thanks. Hi, everybody. I can't see anybody's images, and I don't know if that's because they have cameras off or if that's because it's something about this kind of seminar. Jason, do you know?
No, I do not. I just see a list of people with a couple of faces, not many faces. So I'm not sure.
I think they just have their cameras off, Katey.
Okay, that's totally fine. Everybody's welcome to keep your camera off. We will have one moment where you are invited to make something and share it on the screen. So just FYI with that. If you don't want to come on camera because it's recorded, no problem. Potentially you could point your camera at the thing we're going to make. So welcome, everybody. It's very nice to meet you. My name is Katey Shirey. Jason did a great intro. The only other things to mention here are while I'm a physicist and a sculptor, I make art about physics and I do physics about art. And some of that's what we're going to do today. That's the STEAM thing. But separately, I taught high school physics for a long time. And now I teach teachers about using engineering and art in math and science. So if you're more of a STEM person and less of a STEAM person, that's fine. We're still going to look at how to align integrated lessons using standards. So the reason why this is Minnesota vetted is I've had the pleasure of working with students from the Twin Cities at a Upward Bound camp for about 9 years. and I follow their standards. They used to attend Arlington High School, and that's changed over names now. I've also worked with the Heritage STEM Academy in Minneapolis, so it's been for a couple years. So it's my pleasure that I get to actually bring back my Minnesota knowledge to some Minnesota teachers. And my family's from Wisconsin, so I get to credit a little bit of the Midwest in my life anyway. Other cold places I've been to Antarctica to work on a neutrino telescope. I've been to lots of other fun places doing science and teaching about science. So that's me. I'd love to know more about you. And it seems like people have mics off, cameras off. So maybe we could do this in the chat instead of doing a microphone check. But in the chat, if you wouldn't mind, I'd love to know, maybe just your name will pop up with the chat, but what are you teaching this year? What do you teach? How long have you been a teacher? And what's your favorite letter in STEAM? So if you have your fingers near a keyboard, please introduce yourself so that we know who's in the room so that we can plan accordingly. Thank you so much for putting your names in there already. Go ahead and add in your content areas. What do you teach? How long you been teaching? And what's your favorite letter in STEAM? Jason, you can do this too. Aha, engineering, of course. All right, we got middle school 5 through 8. Woohoo! Art, yes, Amber, awesome. Glad to have some K through 6 here, K through 5. I've got lots of K through 5 examples coming up, so I'm really pumped that you're here. Science and art, love CS and art. Yes, I once had a student tell me that coding was like poetry to them, and it blew my mind. It was great. 19 years on sabbatical. Terrific, Derek. Thanks for coming. Chem and engineering. Oh, I can't wait to see what you come up with today. Second year teaching. Well, welcome. Thank you for being here, Dana. Awesome. Wow, you've got a bunch of really neat courses. Ag. Thank you, Ag Don. Yes, I love seeing Ag come into the high school biology. And Upward Bound students at Arlington. Really? Were you at UWRF, Don? River Falls? That's where we've been. We work with the Ice Cube. Yes, Don, amazing. Yeah, I started there in 2009, and I've been there even through the pandemic. And wow, and now it's a teacher training ground. So if any teachers ever want to do some summer teaching at UWRF, oh man, we just missed each other. You probably know Steve Stevenowski and Eric Moose and Jim Madsen, my heroes. All right, well, thank you all for introducing yourselves. And I really appreciate that. We're going to do a quick fist of 5 here. Yeah, Steve squared is the best. Steve Stevenowski, real name. In the chat, we're going to do this again. Fist of 5. How familiar are you with STEM and STEAM? If you're teaching middle school STEAM, probably pretty familiar. But for everybody on the call, go ahead and put a number in the chat from 0 to 5. 0 is not familiar. 5 is I do it already and I can teach you about it. 5, 4, 5. Woo! Awesome. This is for, the Minnesota State Center of Excellence. So I expect nothing less. Terrific. All right, we got lots of 4s and 5s. Terrific. So today we're going to be augmenting your excellence. We're just going to take it up a notch, thinking about how standards, and in particular, the assessment of those standards, in particular, the verbs used to assess them, can be raised up slightly. This is good for if you need to justify some work to your admin, or if you just want to make sure that you are being rigorous in how you are teaching your STEM and STEAM. And we are going to have a chance for you to pair up and share your stories with one another, share your excellence. So please stay here with us until that point so everybody can learn from one another. All right, I was going to have you do this in the chat. List as many ways you're familiar with STEM and STEAM, but you might have to write a lot. Just list 1 or 2. What's one way that you use STEM or STEAM? If you have to list 5, that might be too many. What's one way that you use STEM or STEAM? Briefly. This is an excellent illustration right here. Connecting youth with future careers. Yes, Elliot, thank you for sharing that. Use it to give students a break from memorization and focus more on creative thinking. I love that. You probably use some cool protocols, some see, think, wonder, some notice wonders. Coding a Native American art pattern. Awesome. Integrating science standards with engineering problem solving in the STEAM classroom. Fabulous, Kelly. That's the ticket right there. Great. So encoding sphero balls, building bridges. Awesome. Great. So today what we're going to do is we're going to do a quick make a balance activity to orient ourselves to the various ways that multiple disciplines can come into an activity in the classroom. We're going to talk about design across various disciplines, and we're going to use a standards aligned planning tool. And then we're going to do that partner planning. Then we're going to share and have some reflections and closing exit tickets. Along the way, we're going to be looking at a lot of different examples, and I'm even going to ask you to help tune up some examples and help to iterate on them so you're not starting from a blank slate. When we get to partner planning, you're welcome to start from a blank slate or start from one of our examples. So trying to scaffold it so that you feel prepared, and feel free to interrupt in the chat at any point or even unmute if you have questions or ideas that you'd like to share. This is your meeting for you. We're just here to help make it happen. So we're going to do the make a balance activity. Make a balance, and that's intentionally in italics. I like to use that as a tool to draw students' attentions to a word, but I underdefine the word. So make a balance. I'm underdefining the word in 5 minutes. You may only use materials that are in the building or even the room that you are in. Don't go far. You should make the balance as accurate and precise as possible. Be very careful you don't break anything. And then I'd love it if we would turn on our cameras and share. But if you're uncomfortable with that, other options are snapping a photo and somehow texting it to your computer to get it on there, or even just pointing your computer at the objects that you make without showing your face. Okay, so you have to make a balance. Now, Minnesota Center of Excellence, Engineering Center of Excellence, I expect that these will be not only accurate and precise, but creative and clever. So ball's in your court. Do you understand the task at hand? Good, thank you, Jason. All right, you've got 5 minutes on the clock. I'm going to mute my camera for 5 whole minutes, and we're all going to make a balance, including Jason, including Melissa, everybody. All right, here we go. Every time I do this, I need a new idea.
Can we share anytime or just at the end of the 5 minutes?
Ooh, good question. Let's let people finish. We're about halfway done. 3 more minutes. I appreciate that you're having a supplies limited experience. Extra points for hands-free. Welcome, Crystal. Thanks for joining. We're making a balance, and you're welcome to try as well. You only have 2 minutes remaining, though. Make a balance. Be as clever as you would like. I can't wait to see him. Oh, this is getting good. Oh, I see pictures coming in the chat. Thank you. Just under a minute left for everybody on the call. This dinosaur is awesome. Who knew the dinosaur could balance like that? That's amazing. Is that a known trick, Monique, or is that the first time you've tried that? Five, four, three, two, one. Time's up. Awesome. That's great. I like it so much. Okay, if you can point your camera at whatever you have constructed or made, see if we can see people's constructions. Oh yeah. Look at that symmetry. I love it. Great use of supplies, classroom supplies. Mine's a little like yours. I had to, Jackie, I had to elevate mine because one of my counter masses was hanging onto my desk. So I had to elevate it, but similar notion. Yours is more symmetrical than mine for sure. Jason, you're showing up. Let's see if I can make you bigger. See, Jason, can't really see it yet. Ah, it's the background. He's balancing blue with blue. Oh, a pen was balanced. I see. I see. Anybody else have one? Jackie, I'm going to spotlight you for everybody. Sweet. Yes. It is a stable equilibrium. Yay. There you go. Good. Thank you so much. All right. So, This is great. We have a lot of different, I hope everybody can see everybody again, or is it stuck on one person? I don't know. Okay. Um, I'm kind of new at Teams. Oh, wow. Trying to get the cow to be raised up. I see. Oh, yeah. I see the pen is your fulcrum there. You've got the scissors balanced over the pen. Very nice. Thanks, Leo. Amber, are you showing us yours? The screen is black. All right, so I saw balances in symmetry. I saw balances in gravitational potential energy. I saw balances around a fulcrum. We could get to torque. We could do all kinds of stuff. So like a lot of stuff in teaching, it's not just about the doing of it. It's about these reflection questions. So in this case, what was your goal in the activity? You can put in the chat again. The chat's working really well. Everybody's being so verbal in the chat. So what was your goal in this activity? Did you have a unique goal? Oh, lost my clay. That's funny. So the goal here was to make something that resembles a word in our vocabulary, this word balance. Utilize the resources around me to solve the problem. Yeah. Wow, look at this one. That's great. It's a stable equilibrium, but it is really far off center. That looks beautiful. I also see a color theme on this one that just came in. Derek, were you thinking you wanted to use all the same color, or did it just work out that way? My goal
I
was to
had an,
not
es-
break the. Go
I had
ahead.
an espresso box and some 3D printed parts from students. So I did what
And
I
the
could
goal,
do.
yeah, and the goal was to not break anything. Thank you. Yeah,
That's
that's
right.
important. Yeah. I've seen examples sometimes where people want to balance the colors, or people want to balance work and life. I've seen examples where people want to balance something heavy with something light, and they just want it to work and they try really hard. So although I said balance, different things can come out of that word. It becomes a word that we already know, right? Like balance is homeostasis. Balance is work-life balance. Kelly says her goal was literal. Use classroom resources to simplify balance while considering how distance from fulcrum affects mass necessary. Fabulous. Thank you so much. Kelly, if you can remind us, is that a learning objective you normally teach, or is that just something that you knew naturally you'd have to balance the distance and the mass?
It's something that I just try to inspire curiosity and in kids to think about the next level when we're, yeah.
Yeah, we have like this really like we have teeter-totter brain, right? We kind of get that if you have something heavy on one side, you'll need to put something heavy on the other. But we also have in our teeter-totter brain the capacity of distance. So Kelly, I like that you brought that in. Those are both really important for balance. It turns out that they happen to be the same on a teeter-totter, but you can change distance. And like if you could move the seat on a teeter-totter, you could change how heavy you need each side to be. That's great. Okay, so I want you to consider how you collected data along the way. You did have to collect data along the way. What was one way that data informed your next actions? Cause and effect relationships, nice. You were getting pretty constant feedback. If I can return my gaze to Jason's image in there. Jason, when you're balancing that pencil, you're getting constant feedback. And that feedback is data. In this exercise, it was very immediate feedback. And in engineering design challenges with students, we often ask them to take more like more intentional feedback, right? And to really quantify the outcome they're hoping for, take data on that outcome, and then iterate their design. In this case, you're actually getting data really, really quickly. So just wanted to kind of put that up there for contrast. Was this a STEM or STEAM activity? Why or why not? What do you think? You can type it. You'll be essentially anonymous. Anybody want to say no? Anybody want to say yeah? I'd say STEM. Not much art in my example, but art is subjective. STEM, yes, we have a goal. We're connecting it to standards. Depends on if you had a color scheme. And balancing is physics. Interesting. Okay, so this notion that it could be art if only we had color in it. We're going to get to what doing art means and whether balancing is only physics or is also art. And that's part of this workshop, is looking at what it means to bring art in and what are the art standards. Lastly, here, I think we've already answered this. What content was the challenge meant to teach? It was really meant to teach the fact that the idea of balance is subjective, and doing something that we naturally already know can be STEM or STEAM when we put sort of constraints around it. Setting a goal, collecting data, using data to impact our next actions, those are hallmarks of the engineering design process. Reflecting on it as well. So this is a really quickie. I recommend doing this as a warm up with students kind of near the beginning of the year. Just get their minds wondering, what do I already know about balance? Little kids, big kids. This yoga lady is on purpose here because sometimes you can have them do it with their bodies, and that can be really fun. Don't let them stand on furniture, but getting motion into the classroom with bodies and with objects can be really fun. So I recommend this as a kind of entry level STEAM, talking about what engineering is by talking about setting goals, collecting data, impacting next steps, etc. And I forgot to mention that you are welcome to have these slides. I'll put that in the chat right now. So if you want to just rip off this slide completely, go for it. Or obviously it doesn't take much to get that slide made. So today, this idea of STEM, STEAM, STEM plus, whatever. I like to say STEAM, but even sometimes I put the A in parentheses because sometimes that's just a turn off for some, folks, but that's what I like. So this is my slide. I like to use, I like to learn by using math, science, humanities, art and engineering skills, and even technology tools to design, invent, and innovate. And I think that disciplinary learning is validated within the problem solving system. So some of you said, I just took this really literally. I needed to use objects around me to create a balance. Well, that learning about what balance is validated by having to make one. So we're going to work on this idea about bringing together diverse disciplines and multiple perspectives to some kind of braided, integrated STEAM braid that's stronger than the sum of its parts. And what does this do for students? So this video blows my mind. This is a video of neurons coming together in a petri dish, but this is what happens in our brains when we make connections. Neuron to neuron connection. If you just wait a little patiently, this is a thought forming. This is a memory forming. This is literally happening in our students' brains all the time. The more connections we can make, the thicker we can make those connections, the more likely it is for that memory to stay there and for it to be useful later. So we really want to bring in, more connections among various parts of our brains, and also to recognize that we love their whole brains. We want to see their whole brain in action. So bringing in the parts of their brains that appreciate music, bringing in the parts of their brains that appreciate movement. That's how arts can help us to strengthen and fortify the connections between content and their knowledge. And I put her link there too, if you want to check out the scientist that made that. So bringing multiple disciplines together. I'm going to ask you to think back to when you were a student and list some of your most memorable assignments for several disciplines and classes. And just on paper next to you, really briefly, this whole exercise will take about 10 minutes. Think back to when you were a student and list some of your more memorable assignments for different disciplines. You teach engineering, you teach STEAM, think about English, think about theater, think about other things. What were some memorable assignments for you? Go ahead and make a quick list, please, on paper with you, just right next to you. Susan, you want to share one? Oh, you've just joined us. Welcome. We're just thinking about some assignments that we remember for various disciplines that are not necessarily the one we teach. And the follow-up to that is thinking about what the objectives, assignments, and instructions were, and whether it was design or not. So my example is I had to write a play in middle school, and it absolutely challenged me. Do you all think that would be designing something or not designing something? Writing a play. All right. Time is up. We're not going to go into small groups yet because we are only going to do the pairs because we've already talked about pairing up with our hosts here. So yeah, some of you guys are saying totally design. Mine was about designing a flower. Whoa, that would be visited by pollinators more often. Awesome. Yes. And someone says it involves visualizing what happens to the character actions. Yes. I think it's designing because you have to think of various components. Amazing. So when we look at how to bring multiple disciplines together, the reason why we're here in engineering together is because engineering allows us to bring design into almost any context. There are so many things we do as assignments or actions in other disciplines that are actually part of designing. And the action is really important here. It's the verb. It's thinking about what verbs work in design and work in other standards. And I'm going to drop into the chat here a chart of verbs. Oh, I can't drop it in the chat. Let's see. I will find a way to get this to you on Dropbox. Gee. Sorry about that, team. Let's see if this works. I heard a bell. Anyone with the link, copy link. Okay, I'll put the link in the chat. Let's see if this works. This is a chart of many verbs. Can that open? Someone give me a thumbs up if that works. The Google Drive link I just put in there. Thanks. So these are verbs and different cognitive demands that are useful for thinking about design in various disciplines. If I look at mine, I can see that writing is in creating. So the task that I did as a middle schooler, writing, was a part of the highest order of cognitive demand, and it was part of designing as well. All right. I want to skip ahead a little bit here to the art and STEAM. I know that some of us are already teaching STEAM, so just to level set, what does it mean to have art in STEAM? Hallmarks of both STEM and STEAM are including perspectives, relationships, and quantities. When we talk about perspectives, we're definitely getting at art. When we talk about relationships, we're definitely getting at art. When we talk about quantities, that might not seem like art, but it is intentional decision making. Art pieces and making art pieces is one way to think about art. Art processes is one way to think about art. And art movements is one way to think about art. In this example here, we're looking at a Calder mobile. It is an art piece. And the making of it involves thinking about torque and center of mass. Those are also physics contents. So the art pieces and the making of the art piece already involves some science. The art process here, I'd have to use some welding. I could use oxyacetylene welding, maybe TIG welding. I'm already getting some science in here with chemistry. And the art movements involved here are many, from kinetic art to surrealism and abstraction, etc. Maybe you can see some petals or some leaves there. Maybe that's bio-inspired art or even place-based nature art. These are art movements that are involved in here, and you're already seeing some science emerge there as well. The whole process of making it, as you've just iterated on some other examples, is designing something for a goal, collecting data on the way, and making actions in relationship to that data I've received. So I'm making the case here that when you talk about integrating art, think along these lines: art pieces and making art pieces, art processes, and art movements. And within the slideshow later, there's a lot more depth on these, but I'm going to let you go through that when you get into your pairs. Now, as far as standards go, standards are really important in art as well. We don't just want to talk about, oh, it looks good or it's aesthetic. We want it to actually be related to standards. Minnesota, and as a nation, has art standards. So I'm pointing you to the National Core Arts Standards. And that link is going to go directo in the chatto as soon as I grab it. The National Core Arts Standards focus around these 4 areas. They are divided up by the type of art. So whether it's musical or theatrical, there's all different ones. And it's around creating, performing, presenting, or producing, and then also responding to art and connecting to art. So creating art, absolutely, Alexander Calder had to make that art. It was presented in a gallery hanging on the ceiling. It is still art to walk in and respond to that art. That's why attending a gallery show is part of art, or attending a theatrical performance is a part of art. And even evaluating your perceptions of it. And finally, connecting, synthesizing, and relating your personal knowledges and experience to make the art. And when you look at art, relating that art with societal, cultural, and historical contexts. So I like to point out here, really importantly, it's not just the doing, creating and performing, that's the doing, but responding and connecting, bringing in an art piece to look at and think about how it connects to the physics, like we just did with the Calder. That is also a national art standard. There are many, 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 many art standards. If you're opening that link right now, you might be like, whoa, Katey, that's a lot. But if you think along these high line kind of the 4 main themes here, I think that's one way to start really drilling into what the art is. All right, so what makes a terrific integrated lesson? In my opinion, these are the ABCs of STEAM planning, and don't judge me that we're going to go out of order, but authenticity and relevance, student sense making, content coherence, disciplinary learning objectives treated equally, equally aligned assessments, fostering STEAM mindsets, and your great teaching moves. We're going to focus on D and E because this is the standards-based ones where the learning objectives or standards are treated equally, and the assessment that assesses the standard is also treated equally. We could have enhancement where one content area supports the other, all the way up to integrated where the lesson plan is co-planned by 2 different content teachers to equitably teach and assess both standards. Now, I'm not saying you have to be at fully integrated right away. Maybe you're already fully integrated in your own classroom, but there's other ways to do it too. Having a lesson that's based on a common theme in 2 areas is totally an appropriate way to begin this journey. Having a lesson in 2 content areas based around the same question. What is movement in terms of landform changes, in terms of dance? Exploring something like what is movement, what is balance in mathematics and in stoichiometry. Those could be an inquiry-driven way to explore a concept in 2 areas that unite the 2 areas. Again, moving towards more integrated co-taught is a lesson that's co-taught by teachers from 2 or more content areas. Imagine we were doing make a balance with our chemistry and our algebra teacher, and then we defined balance in both of those areas after doing the lesson together. So I just want to share this with you. We're going to go now into our planning tool. And I just wanted to share this a little bit with you so that you can see there's lots of options. You have the notes, or you have the slides in the chat, so you're welcome to use those as well to go back and forth when we get into our groups. And Jason, just a heads up, we're going to go into our pairs in about 10 minutes. All right. So the planning tool. I would like to drop the planning tool in the chat as well. And to do so, I now know I have to put it over here and then, nope. To put it over here. This is my integrated STEM Plus planning tool, and you are welcome to use it. I encourage you to share it if it works for you. And I really would appreciate it if you like it, you know, send a little feedback or whatever, but it's just for you to use. When you open it, you should be able to make a copy, and that's going to be important because I just had to put it into my drive. So let's try this. There should be another link in the chat now. You're going to want to make a copy or download it because it's a PDF. So Jason, you mind clicking on that? Make sure it works. Thanks. All right, so it starts with your rough STEM Plus idea. Again, we're using STEM, STEAM, STEM Plus. You can change it however you want. But what you would do here is you'd put in a rough idea to start. And the next step would be to think about your 2 learning objectives. And I would suggest you start with one from your core content area, one of your own learning objectives. On the right, then, you would add in an integrated content objective. And I've done something bad. I can't see the whole screen. Nope. Let's try that again. Okay. So on the right, the integrated content objective or standard. So when you go into pairs, one of the sides will be yours and the other will be your partner's. You're going to try to bring together 2 objectives. Next, you're going to think about, oh, and there's a little note here. It says, it helps that the standard has a higher cognitive demand. That's in reference to the chart we looked at before. It actually is easier to integrate if it's a higher cognitive demand. Turns out, if you're just saying, I want you to identify the 6 fossils in this set of images. Yeah, we're looking at images and we're identifying fossils, but that's not a really rich thing to do. It helps if you go into the higher cognitive demand where you're creating or modifying or reacting to something. For each one, you're going to go vertically downward. How will you assess those objectives? Now, here is where your verbs come in. These are going to be verbs that are embedded in your objective, embedded in your standard. I even like to highlight them with a highlighter because as I go further, and I'm passing here, you're going to show in the next box how you're going to do them together. So moving from how you'll assess them to how you'll teach them and how you'll do them together, the same verbs should appear again at the very bottom. This little symbol is supposed to symbolize that they're getting braided together or wrapped together somehow. All right, let's look at an example on the tool. This is from a teacher I was working with in New York. So she wanted to do a magic milk and soap color experiment. And we tried to figure out what are the actual standards that could teach. It was kind of like a Pinterest idea, really, to start with. And I thought, wow, this is not going to be a very, rich activity. So what we figured out was that from the magic milk and soap color experiment, we could talk about physical and chemical properties of matter. We could talk about how pigment was in the colors. And then when we looked at how art might relate, we thought about a painting by Morris Louis. It's got colors streaming from the edges of the canvas. Morris Louis, American painter. So I thought, okay, now we're getting somewhere. So how would we assess whether they had learned anything about painting by Morris Louis or properties of matter? And she said, well, we could have a quiz on physical and chemical reactions. And I said, well, here's a visual art standard. Explore and invent art making techniques and approaches. So that was an art standard we could actually identify that had something to do with this, quote, experiment. And then I said, well, how do you teach that so that it can do the assessments? And she said, usually we explore animations and physical models like mixing versus cooking different ingredients. And I said, okay, that sounds like something you could do. And I said, well, you could try this art making process and you could ask, how was it novel? How is it an inventive art making technique? We could try dripping colors across various corners of the canvas to make our own Morris Louis. Dripping instead of brushing, dripping. So in the end, our restated idea was students will explore and invent art-making techniques using physical and chemical properties. They will turn in a photograph of their work. They will caption the photo with a description of the chemical or physical process that occurred in their milk and soap and describe the art-making practice they explored and invented. So we took exploring and inventing, and we added in the how to make different property changes and have them describe it both. So that's just one example. Does a tool make sense to you? That's really important to me. First of all, I want to make sure the tool makes sense before we look at some more outcome examples. And I'm looking back at the chat. Does the tool make sense? Any questions about the tool thus far? Thanks for the thumbs up, Kelly. Anyone's welcome to unmute and ask any questions if you have any. Okay. Okay. Well, I'm going to show you just a few more examples, then you're going to pop into a group and actually try this on. So when we get into actually, like I said, the standards to the combined standard, I have some examples here from elementary, and I was pleased to see so many K-5 teachers on here, so these will be right up your alleys. In grade 2, this example was use information from several sources to provide evidence that Earth events can occur quickly or slowly. And there's a visual art example, recognize and describe visual characteristics. So I need to somehow bring together this Earth science standard, which is based on NGSS, using information from several sources to provide evidence that Earth events occur quickly and slowly. And when providing evidence, recognize and describe the visual characteristics of one's natural and constructed environment. So what do? They're going to use visual scanning of images and videos from slow and fast Earth processes to recognize and describe visual characteristics of the natural environment and provide evidence of each process being geologically slow or fast. So we brought together, recognize and describe the characteristics of an image, and we use that information of the images to provide evidence about slow and fast events. See how the verbs really line up that come from one another? This came together because we used that chart. We thought about what we could actually do to demonstrate both of these standards at the same time. I'm going to show another one here. Science, analyze and interpret data from fossils to provide evidence of the organisms and the environment in which they lived long ago. And then a visual arts, create artwork using a variety of processes and materials. So we talked about a lot of options, and in the end, this was the one we wanted to do. Use collage to communicate their understanding of how historic animal and plant fossils may be found in places where the organism wouldn't normally seem to live. Create a collage of then and a collage of now to show the fossil's location changes, and share it with someone else who will analyze and interpret the collage and state the evidence of the changes. So we're bringing together both verbs again. I want to flip forward a little bit here. On my slides, we have some Minnesota examples that are a little more direct Minnesota. These are from teachers who were reading The Boy Who Harnessed the Wind. Probably a lot of you have heard of that book. And they came together with a technology and a science standard, students will build a simple machine using a battery and magnets. And students will explain how a magnetic field works. And their combined objective was students will build a simple machine using a battery, magnets, and explain how the field works. So that's pretty straightforward. All right, and I have many more examples in the slides. I'm just going to go a little quick because I want to get you into your groups. Diagram the wind turbine, add notes about where each of the parts came from. And in engineering, analyze the generation of flow of energy in the system. So over here, create an artifact that combines and demonstrates an understanding of the story and the science and engineering and how they were all present in the wind turbine that William built. So all of these slides are teacher examples. That's an important thing for me to show you what they came up with. You're welcome to look through them if you would like any suggestions. But I'd like to get you going into your group. So you're going to partner up and plan out one idea using the tool. I have a big asset for you here in the chat. It's standards connections in Minnesota. And what I've done is I went through a design process where we started with goal setting, some discovery, ideation, iteration, and then sharing and reflecting. And I layered in various ELA, social studies, science, and math. Oh, I'm sorry to miss you. Okay, please save the tool. Please try it out. Bye. So hopefully this will help you if you're thinking, well, I really want them to ideate in this part of my engineering lesson. Then look for a standard that aligns with ideation and find a way to have them do both at the same time. All right. So Jason, oh, it does? Okay, let me share it separate. Sorry about that. You should be able to view it now if you refresh. Thanks, Dana. I didn't realize that.
Hey, Katey, how long would you like people paired up?
I was thinking 20 minutes, and then we'd have 15 to share.
20 minutes. Okay, you tell me when I can branch them into rooms.
Well, let me make sure everybody understands. We're going to have 20 minutes to be in pairs, and we have an even number of teachers here. So it's going to be just wonderful. You're going to meet a friend, meet somebody new. Tell them what you teach, introduce yourself, tell them where you are, and get into this tool. See if you can come up with a STEM Plus idea that brings together 2 standards from Minnesota. Good luck.
Hey,
Time to
Katey, if you could not put me in a group, I'm gonna be in and out. I'm just kind of listening in as I'm trying to be principal for the day here. So I'm not gonna be a very good partner. So if you could just, Dan is the name on there. If you could just avoid that, that'd be great. Thank you.
Well, that'll work too. And that way, I think then we don't have to make me a partner with somebody. Is that right? Oh, Monique would like to be out also.
Can I turn it into 3 people per room? And then if they're not available, then I don't know how to talk. Right. So then they won't have to talk or whatever. So at least we have multiple. So if that's okay.
Works for me. And
okay.
And y'all, these breakout rooms are not recorded. So just FYI, they're not going to be recorded. So.
Okay. All right. I'm going to kick them in and then I'll see you in 20 minutes.
Okay, great. Thank you.
Thank you.
Are you seeing them move, Jason?
Yeah, they're open rooms. The rooms are all open. We're moving people into their assigned rooms.
There we go. Good.
That's what it says, at least.
Yeah, they all leave this chat as they go to rooms. That's correct. Yeah. There's always too many examples. I just want to give examples and examples, but it's way more fun to have them invent their own.
I wonder if yep, they're all in there. So, okay. They're all in rooms.
Great.
Assigned participants have been assigned. So I hope they're all there.
I'm seeing people in this room yet, but maybe they're just flipping
Well, that's
over.
what and I'm seeing. I opened up
Oh,
the.
Amber's not in a room.
Okay. Let's see.
If you click on the three dots next to the name on the image, can you assign to a room?
Let's see. Amber. I got her to ask to join. It says all participants have been assigned. Assigned participants. Let's see what happens. Oh, yep, they're all set up. They're all in rooms.
Oh, shoot. Well, we could work together in here.
Right, we could work together in here. They're all in different rooms, it says here. And Amber, she should be in room 1. I can put her in a different room. Should I throw her in a different room?
Sure. Just give everybody a
Save
chance.
that. I think.
Well, if people are still here and they can still hear us, I vote we do this together. So it will require some people to unmute and tell us about a rough STEM idea that we could all play with together. And you also don't see an option to turn your microphone on. Well, Kelly, you're very good at the chat. So if you'd like to chat anything about a rough STEM idea, we could just go with that. And I'll type so I can keep track for everybody.
Hey, Katie, should I close the rooms then?
No,
We'll
no,
keep
no.
it-
Let people
okay.
let her in there work on
Okay,
it.
sounds good.
Yeah. Yeah. Thanks, Jason.
Yep.
So we've got Dana, Katie, Kelly, and Amber. And we're going to do it together. We're just going to give it a shot. Okay, that makes sense too. And Amber left. So Dana's teaching high school biology, forensic ecology, middle school STEAM. She's got a solid STEAM background. Dana, do you have anything you'd like to try on here with us? In ecology, I'm focusing on adaptations of animals. Okay. Should we get some STEAM going in adaptations maybe? Here's a possible objective. Apply concepts of statistics and probability to support. Hey, I see you, Kelly. To support explanations that organisms with advantageous heritable trait tend to increase in proportion to organisms that lack the trait. Great. Okay. So a rough idea here is we need to get adaptations and animal adaptations. But could it be any traits? I guess it could be an organism that is more like a plant, but adaptations and something. Should we do like a art objective? Do you want to try history? Do you want to try English? What do you want to try? Adaptations and could be art. Yeah. Well, you have a STEAM classroom, right? So that's a good idea. When we think about those the art areas, right? We had creating, performing, responding, and connecting. I'm wondering, Dana, if you want to strive for one of those that you don't normally do. Just for the practice of trying it. Or maybe there's a type of art. Oh, I'm so sorry. Is it because they're not presenters that they can't turn on the mic?
I was able to turn mine on.
Right. I wonder I can go ahead and physically turn on Dana.
Technically, I'm on hold. I think my computer's struggling. Teams, man. Teams.
That's the same thing that mine was telling me, that I was on hold. So I left the meeting and came back in, and it seemed then I was able to join. So that might be worth trying.
Yeah, and Dana's, I'm seeing that it must be something with her mic, because we're able to communicate here with the rest of the people. So I'm not sure. Oh, her computer's struggling.
So here's some options for the team to consider. When we think about adaptations in art, we have a lot of options. We're going to go get a standard, don't worry. But before we go pick one out, we can choose whether we want to focus on art pieces, art processes, art movements. Oh, good, Dana's back. Hey, Dana, what were you thinking about? There she is.
Hello. Okay. What I don't often do is responding.
Okay. Well, let's then have your newest lesson do some kind of responding to art pieces, art processes, or art movements. Any of those that you don't normally pay much attention to that we should focus on for fun?
Probably the movements.
Okay. So we're doing this as an exercise to stretch Dana's thinking, because Dana already has a functional STEAM classroom. So that's why I'm sort of pushing her to be in an area where she's not normally. Art movements. There's so many great art movements that we can worry about. Let's go pick one. I'm going to stop sharing that and come back to my slides because I've got a big list of art movements that we can all look at. And share again. Man. Here you go. All right, so what you're seeing here are various art movements. Dana, are you familiar with any of these? Do these feel like something you could like that you'd like to get into? These are various art movements. Some of them are like
a few that I recognize, yeah.
What would you like to play with?
Futurism.
Futurism, awesome. What does futurism mean?
Don't know. I just want to know about it.
All right, cool. So futurism, fairly unique among different types of art movements. It is an Italian development in abstract art and literature, founded in 1909 by Filippo Tommaso Martinetti, aiming to capture the dynamism, speed, and energy of the modern and mechanical world. Gnarly. Look at that cool art. It reminds me of like movies like Brazil or sort of future fantastic movies. Makes me think of Bjork a little bit, but I'm also noticing that there's traditional symmetry happening in those sundials up there and other stuff. So that slideshow that I gave you, it has all these hot links in it. And then from there, you can click to learn more. Celebrating the art of movement. Okay, so now we've got adaptation and students responding to works of art or this movement in general that has futuristic ideas in it. Whoa. So I'm asking a lot of you here, Dana, but we're going to get there together. So what we need next is we need a standard that has to do with art and responding and art movements, yeah?
Mm-hmm.
And luckily, I'm going to open up my standards archive here and pull up visual arts and then share the screen separately so we can find a good standard. And how do I share that again?
Is it from that spreadsheet that you had sent out?
Oh, that would be a good place to look too. Yeah. But these are like the actual standards. I just already had downloaded this one. So you see it says visual arts and creating. Remember our 4 categories were creating, performing, responding, and connecting. So I'm going to scroll down to where we get to responding. And then you're in middle school, right?
This would be for high school.
For high school. Okay. So we got high school, high school, high school. Here's some things that they can do as a standard. I'm just going to go to advanced. Analyze how responses to art develop over time based on knowledge of and experience with art and life. Determine commonalities within a group of artists or visual images attributed to a particular type of art, time frame, or culture. Analyze different interpretations of an artwork or collect them, or just interpret an artwork or collection of artworks like an art movement supported by relevant evidence. And those are all our responding ones for high school. So this is challenging, but I'd love it if we could grab a standard from this list We're going to put it in our tool and see if we can make a combo pack of a lesson. I vote we choose this one. It says to interpret an artwork or collection of artworks supported by relevant and sufficient evidence found in the work and its various contexts. It'd be like interpreting the artwork of futurism because we're looking at futurism.
Mhm.
Okay. I see nodding on the screen. Awesome. So let's just borrow this. I'm going to put it into our tool. Interpret artwork or collection of works in futurism, supported by relevant, sufficient data found in the work. Remember how it was all like starbursty and lots of motion? That's a thing we might want to interpret, right? What does it mean to have that happening on the screen or on the image? Or even that sculpture where the guy was kind of running and his flames were coming out behind him. That would be a neat thing to look at as well. All right, so we really need to drill down here. Applying concepts of statistics and probability to support explanations that organisms have an advantage when they have an inheritable trait. How would you normally assess that, Dana? What would you normally do to find out if they could apply concepts of statistics?
Probably if they can graph the data that is provided to them specifically, like based around a certain statistic.
So you'd show them like data of population over time?
Yeah.
Of a what kind of population?
I'd probably choose a particular like animal or species.
Okay. What if it was like a camouflage trait?
Oh, okay, yeah. One classic example is the peppered moth.
Ooh. Okay. Population over time of a peppered moth. Now, what do you think we would do to have them interpret an artwork? Here we could use an art teacher, but we have a STEAM teacher. So how would you potentially have them show their interpretation of an artwork or movement?
Would this kind of just involve them like creating?
Well, we're
something?
responding, so we could respond by
Right.
creating, but I would suggest that maybe in response we'd be articulating, describing. If I look at my verbs, I'm thinking about maybe discussing, maybe inferring, maybe portraying.
Oh, we're still talking about assessment. Okay.
Are we thinking about like comparing a population or, you know, what's happening in a population to the piece of artwork? Like what facets does this piece of artwork have similar to the population, or what stands up, you know, compare and contrast? I'm thinking of that first image that you showed us with all the gears and the buildings, you know, all the mechanical parts, how they might perceive that piece of art and compare it to the trends in the population. I don't know. Maybe that's a off base.
I can chime in a little bit on this one. So like each grouping of art or category movement of art has kind of like a checklist of like this art qualifies for this movement. And so I would have especially with futurism, one of them is blurring, repetition, movement. So just have them go through that checklist and then write a summary of how the artwork like satisfies those like qualities of futurism, which then like eventually leads them to the same qualities of adaptation, evolution.
Say it again. That was amazing, Katey. No, really. Say it again. That was amazing.
Oh, God, sorry. I was like, I would say, yeah, go through like the futurism movement checklist, which includes dynamic movement, repetition, blurring, and then write a summary of how that work represents those within the work, and then apply that to an example of adaptation.
All right, I love this. So I'm actually working a little backwards from how you put it, because you said what you would do first was have them go through the checklist to find the ideas of these characteristics. And then to assess whether they've really learned those characteristics, you would have them write a summary of how the work exemplifies the characteristics. And now I'm going to note that writing a summary, is our, uh-oh, what did I do? I turn on grid lines. Writing a summary is our verb. We're going to write a summary. So over here, graphing the data. So maybe my final thing will need to write a summary and graph data about something.
I would structure it as a claim, evidence, and reasoning, since both objectives lean, so like the art one has evidence in the standard, and then it's incorporating like an SEP into the performance expectation, like from the performance expectation.
So when you're saying how you would teach, was claim, evidence, reasoning up in the teaching, or you want to see that in the assessment?
I would say it as like the final assessment for like blending the two would be a claim, evidence, and reasoning structure of, just because it's easy to grade and aligned more towards the science.
Okay. So you would write a claim, evidence, and reasoning response to describe how the peppered moths, what would you actually have them
like,
write?
I have to structure the question, but I would see the evidence coming from both strands.
Ooh. So if I want to really hit this, I could say, write claim, evidence, reasoning argument for the advantages of the peppered moth's trait using evidence from their population and their patterning?
Maybe. Yeah, I know. I was like, this is where it's like,
No, it's good. Writing the claim, evidence, reasoning takes it a whole other step higher than trying to write a summary, which I appreciate because it requires more evidentiary based argumentation. What if it's writing a summary for the evidence of a peppered moth's visual characteristics and like you could have this be, let's write a summary of how the peppered moth exemplifies the characteristics of futurism. That seems pretty straightforward, but we haven't got our graphing in there yet. How can we get graphing in there? And we're going to run out of time here and just like now. So I don't know, Jason, if you close the rooms, will they have 60 seconds? You're muted, buddy.
Sorry, I can. I'll send an announcement that I'll close the room in 60 seconds.
Okay.
And then I'll close the room. So we'll see what happens. Again, we're kind of flying by the wing. We'll be okay.
You're good. How do I turn off these grid lines, man? It's bugging me. So write a summary for the evidence of a peppered moth's visual characteristics, how a peppered moth visual characteristics exemplify futurism. That might be one thing, but we haven't got the graph in there. So what else could we do to really quantify, the graphing part of this to really get it in there?
Would it be just based on the graph that they made, or is this like just a new piece of content that they would be given, or new piece of data? Because I feel like they could use the graph. If they already graph their data based on information, they should like recall that information within their summary.
Include a summary of the relationship between the traits and the graph. I wonder if you'd actually see a visual difference of like the ones that are more likely to survive because of this camouflage would actually look more or less futurism based on the traits of futurism. Like if you could make an argument for whether something that has better camouflage, like a peppered moth.
All right, I'm going to close it. I'm going to close the rooms right now, so they'll be coming back. Okay.
Okay. Compare the futurism qualities of a surviving VIVING moth. Oh, they're all in the lobby, I guess.
Oops, they're coming. Here we go.
What do you think of that one, Dana? Like comparing the futurism qualities of the surviving moth's camouflage
versus the non-survivors, or like, yeah.
or a totally different species that has a different graph.
Yeah, and then that way they could apply what they learned to a different species.
Mm-hmm. And show both graphs.
Yeah.
Yeah, because then they have to do the graphing thing again for another species, which is a good practice and a good articulation that you can do it.
Right.
And we can also say there's more to this story than just a graph. It's actually a visual change that we can define with futurism.
And then they're practicing their response again.
Yeah. I dig it. Katey and Kelly, what do y'all think? I think Katey might have jumped off, maybe.
Oh, no, I was like, I'm here.
Okay.
No, I think it looks good. Yeah.
Cool. All right. Well, welcome back, everybody. We've been having fun in this room, working through an example. I can't figure out how to turn off the grid line, so it looks kind of ugly. I'd love to hear what you all did. If anybody from any of the sub teams wouldn't mind unmuting and telling us about what you came up with, or even sharing screen. And then I'll be happy to tell you what we came up with. I'm not.
I can start us off.
Great.
So I was with Leo and Monique. We kind of had a hard time just because of the roles that each of us are in. So I'm a 4-H educator, so I'm not really working with any content area specifically. And then Leo is a STEM tutor and works with a lot of nursing students with bio and chem and math topics. And then Monique was with her PD, so she couldn't really help us out much. So we spent a lot of time just looking of like what would be necessarily maybe applicable to us, or maybe trying something that, you know, just would be helpful to have. And we didn't really get much done as far as the document goes, but we did look at a couple of standards and wanted to connect a couple of second grade standards where you would take, so the science standard we looked at is students will be able to represent observations and data in order to recognize patterns in the data, the meaning of those patterns and possible relationships between variables. And then the art standard is identify times, places, and reasons why which students, oh no, sorry, I'm reading the wrong one. It is compare and contrast subject matter from different times and places. So our grand idea by the end of this would be you would have students use rub plates, and with each of those rub plates that would represent a different, that might be a different animal species or plant species. And then you would look at 2 different habitats, and you would rub that plate with one color if it was in each of the habitats. And you do this with a whole bunch of different rub plates and different species. And by the end, you'd have 2 pieces of paper that represent different habitats. And then they could use the colors to differentiate between like how diverse this habitat is if it has a bunch of colors, or maybe this one that doesn't have a lot of colors isn't so diverse. Or you could see, you know, I've got a red owl on this habitat, and I've also got a red owl in this habitat. Okay, that tells me this owl, you know, lives in both of these different habitats. So like I said, we didn't get any of this written down, but this is kind of the idea that we had started to discuss and write down.
I love it. What was something that really challenged you or that surprised you when you came up with that idea?
I I know, Leo, you can hop in too if you want, but I don't want to speak just for our group. But I think the biggest surprise is just, I mean, just in this exercise in general, is finding like not how easy it is to connect a lot of these standards, but like it really, like you look at two different standards and think there's no way I can connect them. But then like you really like think about it for just a moment. It's like, actually, you know what? It's not too difficult to draw a line between the two.
I love it. Yeah. And in a real way, not in like a just color in the different habitats. It's like, let's do observation of patterns and changes along the way, because that's really important too. So I think you really nailed it on that example. I'm going to go ahead and share Dana's example. Dana, are you available? Do you want to talk about it or do you want me to?
I mean, I definitely prefer if you did.
Okay. Well, and this gives me a chance to say how we got here. So Dana said she's about to teach adaptations. She teaches in a STEAM classroom, so she has some experience bringing in art. And so we pushed her to say, well, what of the things that we've already discussed today would be novel and new for your classroom? So the idea of responding would be new instead of creating, and the idea of art movements would be new instead of creating pieces of art. So we looked at the standard about applying concept of statistics and probability to support explanations about advantageous heritable traits. And then we brought in an art standard that we found from the visual art standards, which was to interpret an artwork or collection of works supported by relevant and sufficient evidence. And we were looking specifically at futurism, which is just a really neat art movement that none of us knew too much about, except I believe Kelly knew a lot about it. Katey, sorry, Katey Cat, my bad. So we really looked at how you could write a summary of how the work exemplifies characteristics of futurism. If I'm looking at artwork, that makes sense. But what about if I'm looking at a peppered moth? Could we also talk about how that peppered moth's visual characteristics exemplify futurism? So we wrote that down here, and then we were struggling a little bit to get into some more data analysis because the standard's about statistics and data analysis. So in the end, we came to an idea that's at the bottom here. Compare the futurism qualities of a surviving moth camouflage to non-surviving species, applying what you learned about the different species and creating two graphs to actually show how their survival is different by graph, and having this commentary about their futurism characteristics at the same time. So I want to ask Dana, Kelly, and Katey, was there anything surprising or challenging through doing this that you'd like to share as a reflection to the group? Go ahead, Kelly.
I haven't done much with integrating art into STEAM, so the art standards themselves are kind of foreign to me. So that piece of it, that whole side is new to me. Yeah.
Awesome. Thanks for sharing that. I hope that these couple structures might give you some hope, right? Like creating versus responding and connecting. That's a really great way to think about it. And art pieces versus the processes versus the movements can give you a lot of play, even within those standards, to say, what am I having them respond to? Should I be responding to a movement or just this mural that's on the wall in our school? Think locally, think nationally, think internationally. There's so much art to respond to out there and to connect to our lives. So unfortunately, we're about to be out of time, and I want to make sure I stop early so that we can share any other questions in the room. So with that, I'll call it a day. I'm going to put my email in chat. Anybody have any questions or anything else they'd like to share before we say goodbye?
I really like the template because I'm always looking for ways to just explore different curriculums or contents. And I never can figure out how to actually align that. So it's nice to see it lined up next to each other.
Awesome. Love that.
I agree. I'm a 4-H educator with the University of Minnesota as well, same as Josiah. And some of the things that we struggle with as 4-H educators is that we have these really cool activities, but we don't always apply the standards, or they're there, but they're not always expressed. And so we always have this struggle sometimes because we're academics. And so we have to report this, and there's all of that, and that teachers do as well. And so it's handy to try to um, go through it. And I'm a part of a 3-person team right now that's working on a statewide curriculum for aerospace. And we've just been doing that, of like, how are these activities fitting in with the standards across the state and nationally? Because we're also not, a lot of us aren't trained teachers. We're not licensed teachers, and so like the whole standards things to some 4-H educators are just, it's a foreign concept.
Yeah.
And so we really have to dig into it sometimes to try to figure out what they are, and how it works to what we're doing out in the field.
Yeah, it can really validate those interconnecting activities. I mean, even if you've got a friend down the hall in a school and she's teaching something totally different, you just want to be able to do something more interesting together to keep yourself interested, standards can help make that happen. Take it to the admin, take it to the VP and say, I've got this thing that's going to teach all these standards, but we need the auditorium for 2 days. Or I've got this thing that's going to be really helpful for connecting up what we're learning in a vertical way, maybe 3rd, 4th, and 5th grade together, but I'm going to need a field day to get them all outside so we can do this vertically aligned thing. So I recommend you keep looking at them. The more you look at them, the more obvious they become. Of course, Minnesota's standards are great. The spreadsheet that I gave you before, a really easy way to bring things together is through design. So that whole spreadsheet is about standards related to design. Yeah, and I love doing this with y'all, even online, because I'm looking at some of, like, Jason's face was like, I don't think this is going to work. And then guess what? It works. So take it to a meeting, take it to your friends, see what they think about it. If it looks too cutesy, just turn it into a spreadsheet. That'll work too. And I really appreciate all of your time and all of your attention. I hope we can stay in touch. Feel free to check out the rest of this slideshow for a bunch of ideas. And I have a website with even more ideas on it. So feel free to check out educator.com. And there's an online teaching resources library there that might be useful to you. I appreciate it. Thanks for this opportunity.
And thank you, Katey. And like I mentioned earlier, if you want your CEUs, or if you need those, contact me directly. Katey has outstanding resources, and that's why I wanted to bring her in here. Go to her website, check it all out. And the wonderful thing, it's very, very expensive. It's free. So at the end of the day, that's really what we're trying to do, is bring great resources to you as educators. Here's another resource that we're trying to do. So have a wonderful rest of your day, and thank you very much for all of you attending. And Katey, especially thank you. Thank you for your time and your efforts in sharing this this kind of content. So
yay, go get them, guys. Woo! Have a great day. What a fun bunch.